In this real world example, we are trying to determine whether the ratios are equivalent. The problem is this: Meg is speed walking at a pace of 5 meters every 2 seconds. Sean's pace is 10 meters every 5 seconds. Are they speed walking at the same pace? If not, who is faster? So the first thing that we need to do is we need to write a ratio to represent each person's pace. So Meg's pace is 5 meters. She walks 5 meters every 2 seconds. So 5 to 2. Sean, his pace is 10 meters every 5 seconds. So he is 10 meters to every 5 seconds. Now, first, to decide whether Meg and Sean are speed walking at the same pace, we need to determine if the ratios are even equivalent. So we take a look at them, and we ask ourselves, is there a number that we can multiply each quantity by? So for example, to go from 5 to 2 to 10 to 5, is there a number that we can multiply each of those by to get from one number to the other? So we know that going from 5 to 10, we can multiply by 2. Now, to go from 2 to 5, you cannot multiply by 2. You actually have to multiply by 2.5 or 2 5/10. So this tells us that they are not equivalent because we had to use 2 different numbers to multiply. So not equivalent. Now, we know that they're not equivalent. So the next step is we have to determine who, since we know they're not walking at the same pace, who is faster. So in order to do that, we have to use an equivalent ratio to compare Meg's pace to Sean's pace. Okay, so now we're going to use an equivalent ratio. And so to write an equivalent ratio, we're going to use Meg's pace of 5 to 2. So that's Meg. And then Sean, we're going to use this, use the same distance of 10 meters. And then we're going to fill in the time. So we know to go from 5 to 10, we multiply by 2. And so now we're going to take the 2, and multiply it by 2. And so we get 10 to 4. Okay, so Meg walks 10 meters every 4 seconds. It takes Sean 5 seconds to walk the same distance. Okay, so Sean, it takes him 5 seconds to walk 10 meters. So Meg is speed walking faster than Sean.